So the filament of a 75-watt light bulb may be considered as a black body radiating in a black enclosure at 70 degrees Celsius. Considering the radiation, we have to determine the filament temperature. We are given the filament diameter as 0.10 mm and length as 5 centimeter. So we are talking about two black body, and we have directly given the heat transfer or the heat energy produced by the bulb is 75 watt, and the black enclosure, I mean the part at which the light bulb is radiating, and that enclosure is at a 70 degrees Celsius. But we have to find the temperature of the filament, I mean source. Okay, so let's check how to solve this problem. So this is our solution. I have drawn a very small figure. It may not look like filament. Okay, won't be look like a filament, and there's a simple drawing. We have a filament down here, and it is having an black enclosure. The filament body is a black body, and this the one it's falling is also black body. So it's a black body to black enclosure. Okay, is I mean transfer happened. So we have light bulb having 74 watt, and T2 is I mean this enclosure is having temperature T2, not the filament is having T2. This 343 Kelvin is the temperature of enclosure. This was the question was given in Celsius. I converted into Kelvin by adding 273. So since the black body, its epsilon is 1, and I have written view factor as or as 1. Okay, can solve it in either by applying these two equations. Both way it is correct. Q is equal to epsilon sigma a q1 raised to power minus u2 raised to power, or sigma a f12 q1 raised to power minus u2 raised to power. Because it's a black body to black body interaction, it might be better to use this equation in general. And here the v factor will be 0, 1 to 2. Why? Because every fraction of the radiation emitting from this filament is falls on the black body, or it's absorbed. So no fraction or nothing get wasted. So the form factor or v factor will be 1. So equation get reduced to this basic equation. Or in this equation, we know it's a black body, the epsilon is 1. Either way you can do it. Okay. So and in this question we directly it's not given the area. So area is simply pi dl. We all know that it's pi dl. Uh, so I mean 2 pi r into L. So pi dl will be, we have diameter length. So we get the area. We have to convert it into meter. And the question is given in mm and centimeter. Uh, next, I mean the rest is simply substituting step. So you get the value T1. We have this Q. The energy is generated from this filament for the heat transfer. Either way, it's correct. Okay, it's 75 watt or joule per second. So you substitute that value in the in place of Q, and we got the temperature of this filament as 3229 Kelvin. Okay.